This is a case study demonstrating the use of 3 different URSA tools to quickly assess whether or not a project is going to be worth it. I was reading a journal article and I had an idea for a summer student, but I don't know if this project is going to be worth it or not. I would like to quickly assess whether or not it seems fruitful. I have the journal article here. There's a list of sources. What I would like to do is quickly go and get WISE photometry for these sources to try and see which of them are likely to have an infrared access. In the table here, the author has provided simply a line number and a name of the star, but not right ascension or declination. So the first thing I need to do is to convert all of these names into right ascension and declination. Here, I've simply copied the text out of the journal. So the first thing I need to do is get rid of that entire first column. And I need to make it look close to IPAC table format. IPAC table format is plain text, but it's got some special syntax, particularly in the headers, that sometimes it's tricky to get right. So here is the original. Here is the almost but not quite IPAC table format. I've removed the first column. I've got a pipe, and then object name or obj name, and then a well past where all of the names end, I have another pipe. So that's close, but not quite. So let's go to the IPAC table validator and find the almost but not quite IPAC table. I'm going to tell it to apply name resolution and coordinate transformation. Upload. So it says we don't have a data type. That's not surprising. And it says that we're missing RA and DEC. Right, because that's what we need help with. So I want to have it try and resolve the names. Okay, it's come back. It's given us an option to download the file we uploaded. Here's the link to the reformatted table. So I'm going to go here. You can see that it's fixed the header. It has all of our source names, and then it's added right ascension and declination. At least it's tried. It couldn't find a counterpart for that one. That might matter. So for now, let's save this so that we can upload it to another tool. So from the URSA main page, we want to go to the catalog search. Then from here, we want the WISE, NeoWISE, and then all WISE source catalog. Now we have a list of objects, so we don't want single object, we want multi-object. Now we can go and find that IPAC table file that we just created. And I do want to click one-to-one match. What this means is for each line in my input file, it will have one and only one line in the output. It will return the closest match to within the cone search radius that I give it here. So if there's 3 sources within, in this case, 10 arcseconds, it will only give me the closest source. If there's no source within 10 arcseconds, then it will provide a row of nulls to indicate that it didn't find a match. 10 arcseconds is actually pretty large for WISE, but going back to the original table, some of those are IRAS sources. So I'm going to leave it large and see what happens. Run query. Okay, it's come back. You can see it's got sources all over the sky. This is a derby image in the background, and you can see the sources are everywhere. The default plot it comes up with is just position, RA and DEC. If we scroll down, there's the search results that it found. So you see that it found a match within 0.6 arcseconds to the first one, pretty close to the second one, pretty close to the fourth one, and the fifth one didn't find a match. What about that source that didn't have an RA and DEC when we uploaded it? There that one is. So I asked for 82 sources, and it gave me back 82 lines. Let's check and see what the nearest match is. So if I go to the gears, I can change what's plotted. Instead of RA, I can do just source number, so CNTR01. And then now I want to look at the offset, dist x apply. Okay, so it's not doing too bad. Most of the sources are within an arcsecond or 2, and there's only some that are outliers. So this is good enough for a test. So instead of that, let's put in W1MPro minus W4MPro. That's WISE1 profile fitted magnitude minus WISE4 profile fitted magnitude. If I didn't know the names of the columns, I could have checked there, but I do know the columns. So there's WISE1 minus WISE4. I could add errors if I want, but I'm going to skip that for now. For Y, I want W1MPro. Again, I could do errors if I want. I can change whether I have a circle or something else. I can change the color of the points. I can even map the color to something else or the size. But let's do this. Let's put in for the X label WISE1 minus WISE4. And then for the Y label, WISE1, we want to reverse it to make sure that the bright objects are at the top. I can change the plot boundaries or the aspect ratio, but let's just go ahead and hit apply. Okay, it's a little goofy. We've got brightness as a function of color here. And I think what's going on is that those are the stars that definitely don't have an infrared excess. These guys are so blue because I bet they're saturated in either WISE1 or WISE4 or both. Here, we've got a large population of objects that at least seem to have a large infrared excess. Yeah, so maybe this is worthwhile. I can send my student into the archives to figure out what's going on with that source that didn't have a right ascension and declination. I can send them in to use URSA tools to figure out whether or not those are saturated, and I can have them use URSA tools to investigate those sources and see if their apparent infrared excesses are real. The tool that I would have them use to investigate those things is Finder Chart. So if we go here, we can use the multiple positions that we already generated. We can ask for only 30 arc seconds from all of those surveys, and we can ask it to search the corresponding catalog. Search. Now it has the same chunk of sky for each one of the sources in our list, and it's pulled a catalog for each one of these sources. You don't have to get very far before you can see that this source is saturated in 2MASS. So that might matter for when my student goes to get photometry from 2MASS. But we can investigate WISE too. Oh, it looks pretty saturated at WISE1 and WISE2. So I bet this first source is one of the ones that's very blue in that color magnitude diagram. You can use Finder Chart to investigate individual sources like that. So I've decided this is a good project to give to my summer student.